in a nutshell, it works like that. Today we will mainly talk about PoolParty GraphSearch, which basically provides an API. Robert will go into the details of the API, and on top we ship a couple of standard components to make a cognitive search application happen quickly. So we will give you 2 or 3 examples, and we will also talk about the effort we've taken to make that possible. So one of the one of the biggest advantages of this approach is that you're really agile in a sense to create such search applications. Going back the whole trail, so to speak, you usually work on top of a RDF graph database, whereas GraphSearch can also sit on top of Elasticsearch or Solr, and probably also other commercial search engines. So there are ways to integrate that. In many cases, we use unified views, which is the data transformation and data linking component of PoolParty to bring data into the triple store from various sources. Those sources could be unstructured, semi-structured, or structured data. So you can connect to Oracle databases or to SharePoint, and in parallel, if all those data is linked, you will create, of course, a different view on your data. And that's exactly what we are talking here about today. To make that happen, to bring in the rules, so to speak, how unified views should behave when it comes to semantic data transformation, you need to have 2 other components in place. One is the PoolParty entity extractor. And we will see also it's not restricted to the PoolParty entity extractor. You can also plug in other such tools like the Thomson Reuters Intelligent Tagger. TRIT, also known as TRIT, is another option, or potentially any other RDF-based entity extractor. PoolParty entity extractor is based on custom-made taxonomies and ontologies. That's one of the main benefits you gain from using the PoolParty suite. You can really describe your own knowledge domain quickly and with some help from machine learning. So this arrow back indicates that the system also learns from all the text you feed into the system. And by that you can, with reasonable costs, create your own domain knowledge model. And then later you can mix it up with some predefined ones, some standard vocabularies if you like. In any case, what you always get is a unified views over your data to make that available through GraphSearch, and that's the long story short. So why GraphSearch? There are a couple of other, let's say, kind of similar solutions on the market. So why did we decide to bring GraphSearch to the market? And one of the biggest advantages of that whole approach was already in the subtitle. It's about entity-centric search. So it's about entities and not only documents. And that's one of the first things I'd like to point out. We are all used to search over documents. We've used it for 10 or 20 years. And we are very used to this behavior that when we search for something, we search for documents. But that's not actually the case in real life. When we ask someone else about facts around things, or we want to know something, we're not asking for a document, we are asking for facts. We are asking a question, and then we would like to get an answer. And that's, I would say, one of the main advantages of a graph, of a knowledge graph in the background. It provides you with information and facts around things, around entities. And with PoolParty GraphSearch, we will show that in a second, you can decide between those 2 scenarios. You can even switch between those if you like, and say, okay, now I would like to search for documents, but later I would like to search for facts around a certain thing. So this is one of the first things. Then here are a couple of other advantages listed I'd like to briefly discuss. So first of all, with GraphSearch, it's not, as I've said, traditional search, but rather search and analytics. Analytics also because it it's centered around the idea that you would like to get insights and see the relations between things, see how things are linked to each other, and how frequently probably they occur in documents and so on. So all that can be covered with some configuration only. So that's also this most agile way we believe or can see that you can create quite sophisticated cognitive search applications within a reasonable time. The ones we will show you in a second were created within a couple of hours, and that's really outstanding, we believe. Second, we already discussed entity-centric search. Then the statistical charts you can see here on this little screenshot already is also something we can quite flexibly configure around your data. That's also interesting, probably, than the fact that it's more about knowledge discovery than just document retrieval. Again, this is something which is, for many domains, a game changer. For instance, in pharmaceutical industry, if you want to see quickly facts around a certain test you've made or around a certain molecule, you want to see quickly how those things are related to each other, then it's a different approach taken than just looking up documents in which you might find some text describing that. And last but not least, it's also about personalization. The views you can create on your things, your entities with GraphSearch can be personalized. We will see that we have the notion of a search space introduced, and those search spaces are driven by ontologies and taxonomies, and they are used to create personalized views on certain data sets. So you can make quickly available different search applications for different user groups, maybe based on the same data, but just using different ontologies. And therefore, you will provide other views and other important facts around things. Maybe HR would like to see other facts around employees than maybe the research department. And this is exactly what you can do with PoolParty GraphSearch. We will also see that the plugin system for various recommender systems is quite powerful. So you can plug in recommender systems based on similarity or also rules. You can bring in based on your knowledge graph, or even the brand new PoolParty semantic classifier, which can also be used for a recommender plugin in GraphSearch. And last but not least, I'd like to point out the ontology-driven data access is also something very helpful and quite agile in the sense that you can create quickly or change the behavior of your search applications after several iterations. Maybe after some user interviews, you find out they would like to have other facets to drill down or would like to visualize search results slightly different. You can quickly change that by just using a slightly modified ontology. So as a next step, we would like to explain to you how does GraphSearch work. So what is the basic architecture and what is the next step? How can this architecture be adopted when the scenario changes? And I just hand it over to Robert.
Yes, thank you, Andreas. So here we see the basic architecture of GraphSearch, which is focused on the functionality of semantic faceted search. This search uses the PoolParty APIs and the extraction and search index to implement this search functionality. And the search index is based on either Solr or Elasticsearch as two options that are available here. Using the APIs, we use the PoolParty thesaurus server to apply a taxonomy for tagging to the content, which then semantically enriches the documents that are provided within the search space that the faceted search runs on. And to bring into the data storage this textual information, we also use PoolParty APIs. to transfer this text into the document repositories. So this is only the basic architecture, which we extended a lot in PoolParty 6.1 into this advanced architecture, which also, as Andreas mentioned, provides support for RDF-based search and data transformation. So in addition to this semantic search, we also provide the recommender systems and also data analytics and visualization. And we added a plugin architecture to be able to extend the recommender with custom similarity and recommendation algorithms. And for example, also, as Andreas pointed out, the classification. These functionalities also use PoolParty APIs and extraction search index, but they also can work directly on the Sparkle endpoint as an RDF-based version. And with the RDF-based version, you can not only use the taxonomies, but also the ontologies to create views on the data. And you also can combine a taxonomy with an ontology here. So the data transformation part uses unified views, which is an ETL tool for RDF, to be able to provide content for the search space, where we can not only provide textual information, but also RDF directly. And to create these contents, we also use PoolParty APIs and unified views pipelines, which can be customized to process this data that is then uploaded into the search space. So we can not only work on the document repositories, but also on graph databases directly based on Sparkle.
Yeah, thank you, Robert. I think it's, again, important to point out that GraphSearch can be based on all kinds of data sources. So it could be XML databases, it could be any kind of document repository like SharePoint, Alfresco, or it could be also a relational database. And we will give you a couple of examples in a second. So let's take a look on how GraphSearch works. So this is a first example we built. We'll give you the live demo after the slide. So what we did was we ingested news articles, and those got annotated and classified by two different tagging services. One is provided by Thomson Reuters, called TRIT, the Intelligent Tagging Facility, and it's based on the knowledge graph of Thomson Reuters. So it contains thousands of organizations, places, and connections between those and various other entity types, and it's pre-built, so you can make use of it out of the box, so to speak. And it can be nicely complemented by another tagging service called Power Tagging, PoolParty Power Tagging, which tags your content more or less based on your custom knowledge graph. So this knowledge graph can be built within the PoolParty Thesaurus server. It could contain any kind of structure or entity types and relation types. So you're really free to create or also reuse some existing ones and extend on those. And then you can use those entity extraction and classification services in parallel and push all the results in a single graph database. Now the question could pop up, so what if Thomson Reuters uses the same entities like PoolParty? That could be the case, that there's probably some overlaps. What you can do, for instance, quickly is to say, okay, this entity in the PoolParty graph is the same like in the Thomson Reuters graph. Later in the graph database, of course, that will be mapped correspondingly and will be visualized as one entity. All the facts around the corresponding entities will be then shown as it were one entity. So that's one thing. And all those processes here you see were controlled and managed by the PoolParty Unified Views system. So you can see here the news data was downloaded, it was unzipped, there was some mappings to the URLs imported, all that was converted to RDF. Now, this data got annotated by the Thomson Reuters intelligent tagger, the PoolParty concept extractor. A couple of conversions through Sparkle construct queries took place. Finally, those data streams got merged and again serialized and loaded into a triple store. So, and the triple store, as pointed out before, is then the basis for the PoolParty GraphSearch component. So actually the API of the GraphSearch wraps around, in many cases, around the Sparkle engine of the corresponding triple store. So that's the result of this example, and I'll show you now live how it looks like. So now I'm on that server. That URL will be made available after the webinar, so it will be a public demo example you can access if you like and play around a little bit. So let me explain a little bit how it works. So this is the application, the dashboard, the visualization, which sits on top of the GraphSearch API. I will explain to you step by step what it does for you. So first of all, you see quickly the statistical charts. So you can use any type of entity which was found in one of those documents, or actually, let me rephrase that. This is, of course, as we are all used, okay, we have documents as a result. But just to be clear, it's yet another type of entity. So it can be quickly visualized like that, and now the document is yet another entity type. So in that case, there's just one entity type which we can use, but it's not necessarily always like that. It could be anything else. I will show you already example number 2. So here we've got 2 different entity types. So there's wine and cheese. So you see no documents at all. So those are 2 different types of things which might be related to each other. Like, okay, this wine tastes nicely together with that cheese. That's a typical, semantic relationship we all have experienced and also probably misfits. And that's exactly the main difference. We are so used to document-centric search that we forgot about the fact that we're actually interested in facts around things. Okay, so this news article is, in our way of thinking, yet another type of thing. So with PoolParty, you can first of all drill down and say, I'm only interested in wine. And here you have only one choice. And that's actually what document-centric search is all about. You always look for one type of thing, which is a document. But what we all know, mainly have used already, is, okay, we want to make use of facets. So those facets, as pointed out before in this example, are derived from 2 different tagging facilities. So for instance, companies were extracted automatically based on the Thomson Reuters intelligent tagger. And now I can quickly drill down and say, okay, I'm only interested in maybe, let's say, the Associated Press. So that's the first thing I'd like to do. Drill down and see the results. Okay, and after the first problem we had with the screen sharing, I'm afraid this is the second problem I'm running now into, which is also quite unusual. Let me see why that is the case. Maybe have to just reload the whole thing. I'm not logged in. Okay, great. Yeah, so that's a good explanation for that. Sorry for that. It's always with live demos the same issue. So let's do the same thing. I drill down and use the Associated Press and get yet another visualization. I will see quickly, okay, the countries being used in those 100 results have adopted quickly. Also the sources have adopted. You can also, by the way, remove or change the position of those windows if you like, but that's just a user interface option. Any case, so here you get the results. First of all, also quite usual in the meantime, get an ability here already in the list view to see similar documents. Okay, that's also quite interesting sometimes to find out quickly where is some related stuff. But you can go beyond that. So you can now quickly change the view and go on this interface. Unfortunately, there are no images configured, but with the other demo we will show, you will see that already makes quite a difference if you have images for all the entities. In that case, again, you see companies, countries, entity types, people, organizations, and topics being exposed on this details view. And here the plugins come into play. So you can plug in similarity algorithms. So here is one, for instance, implemented. And now you can traverse the graph. You can start to explore related stuff. Again, see how those things are related to people, organization, or to topics. And we will see also in the other example we have that recommender systems based on other algorithms than similarity calculations can be plugged in quickly. There's also a breadcrumb up here. And so this is a good way to learn about a certain field of expertise. Those charts we will talk about also in a second can be configured and adapted. There are several options for that. Yeah, so here you see a couple of facets which got calculated by either the TRIT or the PoolParty extractor. For instance, the topics are derived from a PoolParty extractor, and this can be configured to whichever domain you like. This is done in the PoolParty thesaurus and ontology server, which you might know already. So this is the first example. Let me go back to the second one, which is about knowledge discovery. So how can things which relate to each other be browsed and traversed in a meaningful way? What you see here in front of you is a way to make sense about relations between different kinds or types of things, in that case, wine and cheese. And that's done through rules usually. And the rules, that's always a tedious work if it, let's say the scripting language is somehow quite theoretic and technical. For the subject matter expert, it's very important to have a tool at hand which is easy to be used. And with the PoolParty knowledge graph editor, you can do exactly that. You can drag and drop in that system and state things like the one cheese is characterized by, let's say, cumene, and cumene works well with a wine which is characterized with high acidity, for instance, and so on and so forth. So that can be done quickly. That's the set of rules. And then later they're executed in the front end. And again, I will show you an example. So that's on the publicly available server with the URL on top. So you can access that quickly if you like. You can pick there, for instance, wine if you like. So you're interested maybe in this one. You see here, again, you can describe the wine here. This, what you see here, you can control quickly with a ontology in the background. You can state how a certain thing should be visualized, which types of facts you would like to display on the user front end. Here you have several options to calculate similarity. So you see the wine cheese similarity is a bit more specific to this certain field of knowledge. The graph similarity is a little bit more on a general level available. And the recommender system here, again, you can plug in several types of recommender systems if you like. Robert will elaborate on that also. So that's the way you can traverse the graph and learn from the recommender systems, learn from the details, and so on and so forth. Here, I would like to change quickly to yet another option you've got, which is about semantic web's research papers. So yet another search engine, which can be fired up in average in around about a day or maximum 2 days usually. So for instance, the news search we produced within 1.5 days. The wine cheese recommender was a bit more tricky because of the rules in the background. So that took us around about 4 days. So here, for instance, you can also change the facet mode. You can say I'm interested in a tree view. And now you can aggregate, any place up to any level of hierarchy you like, and you could say, okay, I'm only interested in stuff around Western Europe, which of course includes all the places underneath. So you can say, okay, everything about Western Europe if you like. And here taxonomies are really helpful because they of course help you to aggregate such filter values quickly. So this is also one option you have to make use of a knowledge graph, and in that case the taxonomical part of it quickly. And now I come to another example number 3, which opens up the space to the unstructured world in SharePoint, for instance. So here you can make use of an application server, the SharePoint power tagging server you can attach to your SharePoint farm and Office 365 environment. Any document, PowerPoint, whatever, Word will be tagged automatically based on a knowledge graph you have described in PoolParty. And this will then pushed into an RDF graph database. For instance, MarkLogic, we've currently done an integration with that technology. So now you can make use of MarkLogic and search over SharePoint content on top of a MarkLogic server. And in the very same server, you have stored other knowledge graphs like Uniprot, Campbell, for instance, if you are working in the pharmaceutical field. And all the found entities in your SharePoint content are then connected to those knowledge graphs by making use of the PoolParty Thesaurus server and unified views component. So as a result, you get the data integrated here. You can attach, of course, also maybe some statistics of your products from a relational database. Again, it will be stored in the triple store. And with the PoolParty GraphSearch, that's yet another option to visualize the data. Of course, you could connect also with other visualization tools like Tableau or KNIME or others. So this is the current architecture we propose. And this was also the basis for one of those real world examples I'd like to mention. So we've been working with a pharmaceutical company for quite a while. And one of the goals there was to make better visible the research activities which are taking place at that company. Therefore, a data integration task has to be made first of all. So PoolParty was used to do the entity linking and mapping between different semi-structured data sources, partly stored in Excel, partly stored in relational databases. And as a result, the research managers now can really see the impact of all the different research activities aggregated throughout a location or whole areas or therapeutical areas and different other dimensions which are important in that field. So PoolParty GraphSearch here also is the search component put on top of the triple store. And I just take a look on the questions. There are a couple of them in the meantime. Let me pick one of those or a couple of those. For instance, let me see, there's one. When I'm doing a graph search, am I searching just over the entities or over the text of the documents as well? E.g., if one of my entities is company name, can I do a search for all documents that contain company name is, for instance, IBM and quantum computing? What about company name IBM near quantum computing. Okay, so first of all, the current version, but Robert, you correct me if I'm wrong, is based on the entities of the underlying knowledge graph. That's the main driver to drill down and filter out documents in that case or any other entity type. What about full text?
Yes, that's correct, Andreas. Currently, we are searching based on the entities and facets, but in the upcoming PoolParty version 6.2, we support full text search also.
Thank you. Next question was, which RDF database does it use? Can we use any Sparkle capable RDF store? So we are integrated with many different vendors. In the meantime, yes, I mean, it's based on Sparkle. It's basically you can use any Sparkle capable RDF store. That's true. I mean, out of the box, there are many options already. And I also have to be clear, it really depends a little bit on other requirements, which one you would pick. It could be about security, it could be about how to deploy the whole infrastructure. Should it be clusterable, distributed? Which scale out capabilities do you expect? And last but not least, of course, security is an important issue in many cases. But yes, the nice story here really is that we are quite compatible with a lot of different vendors. So let us know which one you prefer and we can talk about it. So that would be my answer. Robert, do you have anything to add here?
Yes, that's correct. So we can run on any Sparkle 1.1 endpoint, supporting a lot of stores already.
Yeah. So another question was, can you handle hierarchical facets, e.g. sources followed by date? I've shown a little bit already the way how to handle hierarchical facets. So usually they are controlled by the hierarchies in your taxonomies. And then you can pick the option you like more. So you can say, now just show me the list or show me the hierarchy view on my facets. I hope I've been able to show that. Yeah, can you give examples of successful popular graph similarity algorithms? Maybe Robert has something to talk about that.
Yes, so for example, we implemented Resnick-based similarity for taxonomies. And regarding the wine and cheese recommender, we came up with our own approach, which is based on Sparkle queries. So the standard similarity that you have integrated is based on the properties of the RDF subgraph, actually. So this is a generic approach that basically works on any RDF data without further configuration.
And then there was another question. Thanks for all the questions, by the way. That really intrigues us because you know, it's always good to get interesting questions. The wine and cheese example is just Sparkle, isn't it? Yes, it's all based on the Sparkle endpoint of the underlying triple store. How is GraphSearch different? I see some similarity. What else do I get from GraphSearch that I don't get from Sparkle? I mean, the point is, you know, not everybody is really able to execute Sparkle queries. I would say it really wraps up the complexity of Sparkle to an API. So any, let's say, web developer is able to fire up a cognitive search engine like that. And the nice part is, I think also that it's distributed over several people in the team. So for instance, those persons who are not the developers, but the subject matter experts keep care of good quality of knowledge graphs, so they can be managed in the PoolParty interface. And with the system, with the machine learning components, the system learns from unstructured text. That's the thesaurus part, ontology part. So this is one group of people, and you have the others doing probably these specific recommender engines. They are capable of writing complex Sparkle queries. And then there are yet another group of people being able to writing or developing configuring actually the actual end user application on top. And you know, we are all aware of how hard it is to find a data scientist who can do everything like that. So most often this is really distributed over more than just over a team of people, and it's not just one person who can do that. So it's actually also a proposal how to build such cognitive search applications quickly and make that happen. And so it's just a methodology once again to develop such quite complex applications with very, very little time, in a very little time frame. So this is also something I'd like to point out. It's an economic reason you could pick this approach and not another one. Robert, anything you would like to add?
Yes, so also the recommender supports plugins that you can develop yourself. So you're not limited to what we provide, but we just provide an interface, and you can plug in your own recommender and similarity plugins, implementing your own algorithms, which can be based on Sparkle or everything else that you like.
Yeah, we will also give a quick example how to make use of a classifier. So the PoolParty classifier, it's something we developed for 6.2. Give you a sneak preview here. So for instance, you can classify here documents with regards to which drug is described or is related to this text. So there are 3 different drugs of cell gene. And then some maybe query comes into the help desk, and you can use a classifier here. Most probably I'm logged out once again, have to log in once again. So in any case, you can use a classifier also to do recommendation. That means you can plug in, for instance, when think about a help desk and a ticket system, and you would like to find out which is the right expert in my team which could handle that request. And you can train a classifier with the PoolParty Semantic classifier. You can use different options from here, like deep learning or SVM. And then with selecting the right features, including concepts from your taxonomy, you can reach quite a good F1 score quickly. And that can then be plugged in to the GraphSearch once again. So that's another option that's not based on Sparkle then, obviously. Okay, but maybe let's do the rest of the questions at the end of the session. We have roughly spoken 12 minutes to go. And now we go a bit into the technical details, how to configure stuff and so on. And Robert will guide you through that also, maybe with the concrete explanation.
Yes, thank you, Andreas. So here we see the GraphSearch admin dashboard, which can be used to create and configure the search spaces for GraphSearch. So we start with obviously specifying a name for the search space, and then deciding on which data source it should run on. So as we already pointed out, we have Solr and Elasticsearch, these classical options, and then all the triple stores that are supported in PoolParty also, including the PoolParty Thesaurus projects that are made public and provide also a Sparkle endpoint. So it can also run directly on a PoolParty Thesaurus project, in addition to any other Sparkle endpoint. So for configuring the search facets that are available, and also for the document details that we saw earlier, you can provide either 1 or 2 custom schemes on ontologies that are defined in the Thesaurus manager to create different views on the data. So these can be changed dynamically afterwards. So you can basically switch whenever you like to a different custom scheme or modify your existing custom schemes to modify the view that you have. And this will create the facets that you have available and also show the document details. Also, you can specify here a number of facets per field example and then some minor stuff. So then below we have the charts configuration. So the charts we saw earlier can be configured. So you have different options to create different visualizations for your data. And finally, the mappings, which are used when your search space uses an RDF-based data source to create definitions on how your entity will be represented. So you specify predicates for title and description, and also, for example, for the images that we saw in the wine and cheese recommender. So this you can configure this freely and also dynamically to adapt to your data that is represented in the search space.
Robert, one question at that point, where exactly you configure the facets actually?
So the facets are here specified in the facet models, which provides an autocomplete based on the PoolParty APIs that retrieve the available custom schemes. So you can select here one or more custom schemes that will automatically generate the facets.
And I think one of the big advantages of this approach also is the facet is not just a kind of a class of the model, but it could be a predicate also.
Yes, of course. So you have the classes available and also the relations and attributes. So you can navigate these properties based on resources and also on literals.
So I can give you an example maybe. Again, for the wine and cheese recommender, which is on that server. So those are the search spaces. So I pick now another search space, and let me see here, for instance, the wine descriptor would be a predicate, which means wine is characterized by, and this is yet another value here you find. But this is actually a predicate, which is a relation between two object types in your knowledge graph. So this is also something we were not that easily, we did not have that easily at hand with a traditional data model, a relational data model, or just a tagged, content only, which is what we usually get from a document-centric search. And then the GraphSearch API, maybe we could talk about that a little bit, Robert?
Yes. So GraphSearch also provides a web-based API that you can use to integrate the GraphSearch functionality in your own software components. So of course you can upload and tag document content. We provide endpoints for retrieving RSS feeds to include in the search space, and also URL-based retrieval, where you can specify URLs, and the content is also automatically extracted from this URL and included in the search space. So also the faceted search is available via API, including exporting the search results. There we also have a plugin architecture, so you can customize how your export results should look like. And finally, we also provide the similarity and recommendation functionality via API. So this is a very powerful function that you can retrieve recommendations and include it in your own software components for further processing.
Yeah, thanks for that. Maybe just quickly look at it. So here is again the admin dashboard with the configuration. As Robert explained, you can configure stuff here, and here the charts can be configured. And finally, mappings, for instance, how the description should look like. And that's also the order. So if this is empty, the next one will be taken, or the next one, or the next one. So also that can be done. For instance, images would be a typical example. If a thing has an image maybe attached to another property, then the first one, it will take the second one and stuff like that. And then up here, you can create your yet another search space. So that's one. And then the API, also you can access quickly the GraphSearch API up here. And Robert already elaborated on a couple of those, but it's much more than that. You have here the agents, heartbeats, the facets, the charts, the export, the recommender, the search spaces. So it's quite extensive. You can build your applications based on that APIs. Okay, so let's close up and wrap up a little bit, and then we can open up the microphones, and some of you might have 5 minutes more, and we could do an interactive session. What could be next steps? So first of all, if you're not familiar with the PoolParty taxonomy and ontology server, there's a free demo version. You can quickly register there and play around in a sandbox. There's a PoolParty GraphSearch server out there, which is an online demo server you can play around. That's the second option. So all of that can be found in this downloadable presentation file. All the links. There's a white paper, the next generation of knowledge discovery. There is a landing page for the whole thing, so where you find probably also other stuff. And maybe you're also interested to learn more about TRIT, the Thomson Reuters Intelligent Tagging. You will find information on that webpage. The PoolParty Academy helps you to learn more about semantic web technologies. It's 3 tracks. There's track number 1 for free, the semantic technologies training. You can apply for a C tier on that URL. You can get certified. And track number 2 and 3 is about knowledge engineering and how to integrate semantic technologies. Last but not least, how to make use of GraphSearch. And if you are interested in learning more in the context of your organization, I'd like to point out the Semantic Web Starter Kit, which is a 10 to 20 day effort based on a prototype we create together with you based on your data. You will learn how to make use of GraphSearch, unified views, and other methodologies. And we will also help you to create a roadmap to bring semantic technologies in combination with your data integration and maybe other efforts in your company to life. So I hope you enjoyed the session. I apologize once again for this little outage in the beginning where the screen was black, but that was more the general introduction. So I think there was not a strong need to visualize the information. And later, thanks to our participants, we found out that the screen sharing was not set on. So sorry for that. So please feel free to reach out to Robert or to me. And now I'd like to open up the microphone, say once again, thank you very much. Whoever wants to stay in the room, please feel free. We'll spend a couple of more minutes and discuss things. I'd appreciate your questions.